Hello everyone. I, Dr. Sandhya Tapadia, welcome you for the new session on data visualization using R. Data visualization has its roots in the field of statistics. In particular, it is considered as branch of descriptive statistics. However, as both design skills and statistical computing skills are required to visualize the data effectively, we can say that it is both art as well as science. So we can say data visualization is an interdisciplinary field that deals with the graphic representation of data. As we know, there are two types of data: categorical and numerical. Okay, the categorical data represents groups of objects with a particular characteristic. Categorical variables can either be nominal or ordinal. Nominal variables, for example, gender, has no order in them, while ordinal variables are categories with some order. Generally, we use bar chart and pie chart to represent the categorical data, whereas the numerical or quantitative data is of two types. Here you can see interval and ratio, but that is basically discrete and continuous depending on the values the data takes. Okay, we use histogram and box plot to represent the numerical data. So today we are going to learn the representation of data in R using bar chart, pie chart, histogram, and box plot. So here you can see my R Studio has been opened. The data frame which we will be using for today's session is empty cards, which is readily available in R. We will be learning how to draw various graphs using two ways. One, with the graphic commands available in R, and other using the package ggplot2. So one must have ggplot2 installed in R, and we must call library of ggplot2 before starting. So as you can see over here, the very first thing which I'm doing is I'm calling the library for ggplot2. So now we are ready to go and use the ggplot2 package. By the way, a very basic question one can ask is why we need to use the package if we have the commands available in R. All right, so its answer we will see very soon. Let's first check out for the data frame empty cars. So empty cars is a data frame with some 32 uh, rows and 11 columns. All right, and here you can see there are the names of the rows are uh, represented with the help of, there are some names of the cars which we can see like Mazda RX-4, Duster, Mercedes 230, and so on and so forth. The variable names probably we may not uh, get the idea of what they are actually representing. So for that, we will take or we will use the help command. So here in console, I have typed question mark empty cars and I'm pressing enter. So in the files and plots window, you can see the description of the data frame empty cars. So empty cars is basically the data which was extracted from 1974 Motor Trend Trend US magazine, and it comprises fuel consumption and 10 aspects of automobile design and performance for 32 automobiles, basically 32 different cars. Okay, so it is a data frame with 32 observations on 11 variables. Here they have mentioned numeric because all the variables are represented with the help of some numbers only. Only difference which we can probably observe over here is some of the variables have very specific values. Like say for example, if you check out the column for AM, it has entries zeros and ones only. Okay. Similarly, if I go to CYL, you can see the entries are of the form 4, 6 and 8 only. Okay, so we can figure out that some of the variables are categorical and the others are numeric. Okay, even the descriptions of the variables have been given over here, which you can see. The first variable MPG is representing miles per gallon. CYL is number of cylinders in the engine of that particular car. DISP gives you displacement in cubic inches, and you can see the others also. AM shows mode of transmission, where 0 stands for automatic and 1 stands for manual. And we can see some other variables as well. If anyone is interested, they can read the note as well as the source from which this data has been obtained and so on. So R provides this feature for all the data sets which are available in R. Fine, let's start. Now we are interested in finding out the bar plot. Basically, here as I said, we could figure out that CYL, that is cylinder, is a categorical variable. And so for that categorical variable, a very basic command which is available in R is bar plot for CYL dot frequency. Now, what is that CYL dot frequency? Here, what we have to do is the variable which we have to consider, we need to find out the frequency of a particular value. Okay, so for that, we need to create a table which you can see over here. Okay, so I've created this table which represents the frequency of corresponding to every value for the variable CYN. Means what? From the data, we can observe that there are 11 cars which has 4 cylinders, 7 cars which has 6 cylinders, and 14 cars which have 8 cylinders in the engine. Okay, and then once we have this data for the frequency of the categorical variable, then we can probably plot the graph. So this is a very basic bar plot for CYL which you can observe over here. Now, someone could find this very uninteresting because we are anyways talking about only one variable. So is there any way where we can talk about more than one variable? So obviously there are ways where we can consider more than two variables, more than two categorical variables, and we can actually plot the bar plots corresponding to them. Okay, so here let us consider two variables, namely CYL and AM. CYL, that is number of cylinders, and AM is mode of transmission. So where we know that 0 stands for automatic and 1 stands for uh, manual. Okay, so once again we need to create a table of frequencies corresponding to the two uh, variables. So for that we have this command cyl dot freq dot matrix, and we have, so basically this is the name of that matrix which we are trying to create, and it is obtained with the help of the command uh, which is given in table. Okay, so let us check how does that look. So variable 1, that is AM, it has two levels, 0 and 1. They're automatic or manual, isn't it? Variable 2, as we can see, it represents I mean 6 rows, but values are 4, 6 and 8 only. Okay. And from this we can observe, from this table we can observe there are 3 cars with 4 cylinders which have automatic mode of transmission. Similarly, there are 8 manual cars with 4 cylinders and so on. In this way we can have this table, and with the help of this table now we can have a bar plot which is far more elegant than the one which you can see right now on the screen. Okay, so let me first run the command and then we can see the various aspects in that particular command. So here, if you can see this, this is the bar plot. Here on x-axis, the names are with 4 cycle, 6 cycle, 8 cycle and so on. Whereas the on the y-axis, the values have been taken from 0 to 12, and you can see that the dark or the black color is showing the number of automatic cars, and the gray one is showing the number of manual cars. So this is how one can have a sleek bar plot. And let us check what are different aspects in that particular command. So here the basic thing bar plot we have called the matrix. Okay, then you can read that here it is beside equal to true. Beside equal to true means the 2 bars which you can see for the variable with 4 cylinders, the 2 bars uh, are besides each other. If I put here beside equal to false, I will get a stacked bar plot. So let us check. See here. Now if you can see this, now one bar is over the other. So that is how this beside command works. So let me have it as it is. So what about horizon? Horizon is equal to false. Basically horizon means horizontal. If I want, if you can observe over here my bar plots, bars are vertical. Okay, if I have the horizontal thing is equal to true, let us check what does it give. Can you observe that? Now my bar plot is, it's looking different, isn't it? Because I have the horizontal bars here. Okay, and one more important thing which you can observe over here is it is LAS equal to 1. This thing makes sure that the names of these horizontal bars uh, are written in a proper manner. Okay, else they will be written along y-axis and then it will be difficult to read. Main gives you the title, and the last two things, names dot arg, it is for the names which are below every bar, and the last two are for the legend. Legend means this right hand corner which you can observe, which tells you which bar is showing which color. Okay, I mean which color is showing which mode of transmission. So that is the legend. Okay, now let us check out what happens if we use ggplot2. Okay, the basic command for ggplot2 is this qplot, where we have to use the factor of that particular variable, and geom is bar. So let me run the command. So if you can observe that once again, I got a histogram on a click of single command. Okay, but as I said, I'm not interested in the histogram with only one variable, but I'm interested in the histogram with two variables. Okay, so let me run this command for uh, such graph with the help of ggplot2. So once again, if you have observed over there, it was qplot command. So if I run that, let me check what has happened. So is there anything? Okay, okay. So qplot, if you observe, it is okay. First check out the command. So the basic command follows as it is, that is factor empty cars.cyl. Here geom is blank and fill is equal to factor empty cars $am. So that fill command, it basically decides which bar should be filled with which color. Okay, then you can check out for the labels on x-axis and y-axis. Then main is equal to bar plot, means it will show you the title of that bar plot. So then geom bar position equal to dodged. So dodge means again the bars would be besides each other. Okay, and then so here by default it generally takes position to be stack. Okay, then we have scale x discrete, its labels you can see. Then scale along y is continuous with the sequence from 0 to 12 with the difference of only two values which you can see. So and then we have the labels for the legend. All right, so let us check for this particular command what happens. So that is the thing. See, can you observe this graph? It has given everything. This bar plot, it is horizontally placed. It has the name with 8 cycles, 6 cycles, 4 cycles, etc. This is the legend, that is mode of transmission, auto and manual. And yes, that's how we can get the bar plot with the help of ggplot2 as well. But then why one should choose ggplot2 and why we can't go by the commands for the graphic commands which are available in R? Okay, the most prominent advantage of using ggplot2 over base R graphics in this case lies in the fact that if you remember, we had created initially the frequency matrix before using the graphic commands. Okay, but in ggplot2 we need not create any frequency matrix. That um, uh, that care for that frequency matrix is taken by the package itself. Okay, so we just need to give the command and the plot would be generated. We need not look at the frequency table for the uh, categorical variables. So that is the basic difference. And here now you can go on checking, you can go on changing various things. Here probably if you want, you can put the position to be say stack, or then you can also may change the name and whatever changes you feel like doing, and you can just check what is the corresponding effect on that bar plot. So one can do trials and errors, and you can explore different geoms over here, which are, say in the first example it was bar, in the second it was blank, and so on. So what are their actual properties, when to use bar, when to use blank, that we need, that one should explore on his own. Okay, so let us check out the pie chart. It's a very basic thing. So once again, for pie chart, we need to have a categorical variable, and we need to create a frequency table for that. So here I've created the frequency table for empty cars $CYL, which you can see over here. So there are 11 cars with 4 cylinders, 7 cars with 6, and 14 cars with 8 cylinders, and so on. And the very basic command is pi of that table. If you can see over here, so command is pi of this table, and the labels are with 4 cycle, with 6 cycles, and with 8 cycles. So these are the labels which would be given to the compartments. Then colors, we can choose the colors for the compartments. They could be red, green, yellow, it could be anything, white, black, gray, whatever. And this is the name. Main is, it denotes the name. So let me just run this command, and it will show you the pie chart like this. So with 4 cylinder, it is denoted by the color red, then 6 cylinders by green, and then we have the yellow color. So this is how one can express or visualize, one can visualize the categorical data with the help of bar plot and pie chart. Now let us go towards a quantitative data, and for that we need to plot histogram. Okay, so in this empty cars data frame, if you observe the remaining variables, say for example, if I have HP, you can observe that some numerical values have been taken over there. So HP is, it denotes horsepower. Okay, so for the histogram, let us use HP. Okay, so the basic command, as you said, so here also we have two ways. One is with the help of graphic commands in R, and another is with the help of ggplot2. So we'll be exploring both. I want you to just check out for this empty cast dollar HP. If I enter this, you will be able to see that the values are ranging from, say, 65, I think it is this 62. Okay, 62 seems to be the smallest one, and the values are ranging from 62 to 335, which you can see over here. So a lot of values have been considered. It's quite a, I mean, decent range is there. Okay, so the very basic command is this, which give you a histogram like this. But can we make it more interesting, more what we can say, uh, elegant? Okay, so for that, let us use this command with some additional features. Now can you observe that now this graph is more sleek or more elegant than the previous one which we had. So here basically what did we do? We divided this uh, range from 0 to 400 with the intervals of 25, and on that we tried to draw the histogram, which gave us more clear picture than the previous one. All right, and now can we add some, if we have some mean or line for the mean or line for the median, or we could locate the mean and median for the given data, it would be of great help. So for that, the command is AB line. Okay, so this command is used to draw a line on the histogram. So we want the lines corresponding to the mean and median for the variable HP, and let us do that. So let me, yes, run this command. So you can see that I have got two lines, but then I don't know which line stands for what. Okay, so I need to add some legend over here. So let me add that. In the next command, I have added the legend as well. If you can observe it over here, I have got mean with this line and median with, yes, mean is with dashed line and median is with dotted line. All right. So yes, this was using the graphical commands uh, in R Studio. Now let us go for the ggplot2 command. The basic command we can see is just qplot. See here, for qplot we need not even have to mention which kind of variable it was. Okay, qplot works for the categorical variable, it worked for the numerical variable as well, and the package itself decided that the graph should be a bar plot or it should be a histogram, isn't it? So this is the care which is taken by the package, and it makes our life quite easy. And now with features, once again we can see that the basic command remains as it is. Then we have the geom blank. Main means the title for that histogram. Along x-axis we have the label HP. Then geom histogram colors are say black and white. Okay, and the x-axis has been broken into the range of 0 to 400 into the intervals of length 25. Okay, and then we have the geom v line. Okay, the x-intercept for the mean and the median also, the lines we should have, and legend is added. Legend is equal to true, so the legend is also added over here. Okay, so let us check what do we get with this particular command. See how sleek the histogram is now. Can you observe the difference between the previous histogram which we had and the histogram with these particular commands? So here you can see the mean. It is with dashed lines. Medians I have shown with the dotted lines. So we can figure out that uh, median is somewhere close to 125. So it is less than 125. So probably it would be somewhere around 123 or 124. And the mean, it is close to 150. We can say that it's around 145, 146, and we can actually verify it with the help of the commands for mean and median and all. Okay, so that was for the histogram. And just for the sake of completeness, I'm showing you the basic command for the box plot here, because I just can't resist myself to tell you about this graph as well. Okay, so let us run this command and you can observe the box plot. So here the different horizontal lines which you can see, they represent uh, some interesting values. So this is the lowest one, this is the highest one. The line which you can see over here, uh, I mean, we can say that the lower side of the rectangle, it is the first quartile. The dark line which you can see is the median. The upper uh, side of that rectangle is the third quartile. And one point which you can see over here, it could be treated as an outlier. So that is the feature of box plot. Okay, so fine. I want you people to explore more about the commands for the box plot in ggplot2 as well as the graphical commands in R. Okay, so yes, with this we have covered data visualization in R. In particular, we could visualize the data in terms of a bar plot, pie chart, and histogram with the help of graphics command in R as well as with the help of ggplot2. All right. So let us stop over here. This is Sandhya Tapadia signing off. Happy learning hour. Bye bye.